So we help you gain an intuitive introduction to the doubly linked node and also doubly linked list. We learn about how you can declare Java classes, namely node and also doubly linked list classes, to be generic, and also how we can initialize an empty generic list by having just the header and the trailer with no nodes in between. That's what we have got so far. And make sure you review all the concepts that we have spoken about before you move on to learn about how to define the basic operations for doubly linked list. And I would like to give you one more reminder about the extension that we are doing. So you should really think about the doubly linked list is essentially a singly linked list with two extensions, right? So what are the two extensions? And you want to know about their purposes as well. Right, the first extension is about a previous reference. So rather than just the elements, next, in the case of the singly linked node, we're also adding the previous reference in the doubly linked node. And the previous reference is really trading the space for time. So we are trying to improve the performance of any methods that's kind of similar to removing the last node in the list, right? So what we could do instead is to really get to the second last node, which will be necessary for our removal purpose. In that case, you can simply say get previous and get previous. It's only two method calls over here, two lookups. Each one of them will just be constant time. So overall, it's also constant time. The second extension is by introducing the so-called sentinels or guards, and namely the header and trailer. Both of them are individually just nodes, but they don't really store any meaningful data. And what's really their purpose? Their purpose is really to make sure when you actually write your code, the logic itself can be simplified, right? Let me give you a little bit like a overall, like a high-level idea. We'll definitely see the details when we get to the method implementation. So let's say whenever you want to do insertion, right? If you want to do insertion, rather than having to consider the edge cases, which I spoke about, right? Remember before I talked about the intuitive introduction of doubly linked list, I said about there are two methods at least. In the case of the singly linked list, you have to explicitly write if conditionals for edge cases, right? But in the case of the doubly linked list, by introducing the header and trailer, we no longer have to do this. The idea would be we can uniformly actually perform any kind of insertion, right? So let me show to you, for example. Let's say over here, you may just want to insert to the front, or you may want to insert to the middle, or you may want to insert to the end. All these three cases can be done uniformly by using the idea about inserting in between the two nodes. So we're gonna define some helper method for this particular purpose. That's something you will see. Right? And you don't really have to worry about whether you are dealing with the very head or the very tail of the list. Like in the case of singly linked list, you no longer have to. Right? So these are the two bullet points I would like to mention right away, rather than summarizing them at the end. So right at the front, you want to know exactly whenever we talk about which extension, you should know which purpose we are really trying to serve for our developments. Alright, so the first kind of operation I would like to speak about for doubly linked list is for insertions. So here is simply just one more like a textbook diagram, which I can just refer to you, but you can definitely, I will draw hopefully a much better diagram when I actually illustrate to you, but I'll just include it over here for your reference. You can take a look at that maybe a little bit later. Right, so what I want to do is I want to explain to you this particular helper method. It's called add in between. Over here, right? I'm going to explain that precisely, and then we're going to talk about its running time, and then we're going to talk about how to use it for different scenario of inserting into the list, whether we want to insert into the front, insert to the middle, or insert to the end. In each of the cases, we can simply call the add between helper method. That's really the idea about using things uniformly. So let's talk about this helper method, which is actually a mutator, so that's why it's returning void. Add between. So we got three input parameters. Let's talk about each one of them just to get a clear idea what should be the input and what the output should be. So the first input is called E. Over here is actually a reference to some data objects, which the new node that's to be inserted in between is going to store. And also we got the pred over here standing for the predecessor, and also we got this input parameter standing for the successor. Okay, and it's we are making the assumption that, let me highlight it, the predecessor and successor are directly connected, right? Meaning that the predecessor, its next node, is the successor. Symmetrically, for the successor, its previous node is actually the predecessor. right? It's really important to actually see that assumption. Right, so the pred here stands for predecessor. Let me just write better. And this one over here is for successor. You don't necessarily see exactly why we would call this the predecessor and what this is the successor. But once we insert a node, finally you will see this will be the predecessor of the inserted node, and this will be the successor of the inserted node. That's something we'll see, right? Right. Let me just highlight it here, also in green. This predecessor, and that's the successor. Okay. And we're going to execute 4 lines of code. 1, 2, 3, and 4. And at the same time, you can also think about what the running time is, which we're going to talk about as well. And for each line, we're going to trace it together. And eventually, what we want is to have some node inserted in between. That's what we want to achieve. That's kind of the outcome. Let's trace line by line. Line number 1, we're going to call the constructor for the node class, right? And then we're going to set the data elements, the previous node, and also the next node. That's what we're going to do, right? Let me now create that particular node object over here. Let me put it here. And I'm going to make it, okay, that should be around the right size over here. And then this is going to call new node. Okay, so I'm going to just put some pointer over here. It's called new node. And of course, it's good to be consistent with the color. So that should be blue over here. And then, so this will be the previous node. And this will be the next node. Right? I assume that you're already familiar with the constructor for the node class, so I don't need to review that. Right? You can definitely look at the previous part of the lecture just to review about the constructor for node. And so the previous reference for the new node is going to point to wherever the predecessor is pointing to. And the predecessor is pointing to over here. So that means the previous node is actually going to point to here. Right? Symmetrically, the successor output is actually going to be set to the next of this new node. So next is going to point to wherever the successor is pointing to. Right? So these are the 2 pointers we want to set up at the same time. And also its data element is actually going to point to wherever E is pointing to. Right? So there are 3 pointers we want to set up in this node construction. Right? Let me do that. So number 1, we're going to make sure that the next is actually going to point to the successor. And also the previous is actually going to point to the predecessor over here. And also the elements is actually going to point to wherever E is pointing to. Right? So these are the 3 pointers that we do. I can even just highlight them, number them. 1, 2, and 3. And this part is 1, and the predecessor is actually 2, and the successor is actually 3. Right? So just make sure you understand that. Right? That's only on the halfway through to really insert a node in between. We are not done yet. Let's now move on to the next line. And the next line will be, let's say, orange. Okay? So for this line over here, we're going to say predecessor node dot set next to be the new node. So that means we're going to say the predecessor over here, its next node is going to point to, rather than here, but rather is going to point to over here, right? Wherever the new node is pointing to. So let's do that. So the predecessor dot next, rather than pointing to over here, is actually going to point to this node over here. Right? That's this line. Pretty easy. And the next one. What about this line over here? The successor's previous node should be set to the new node. Right? Kind of symmetric. So we're going to set the successor over here, its previous node, rather than pointing to over here, is actually going to point to this particular node over here. Right? That's over here. And of course, we want to make sure, since now we are in the context of the doubly linked list class, so we're going to increment the size as well. Right? That's why we say it's a helper method that we're going to call in other actual methods that we want to increment. All right, so let's now summarize about what's really being achieved over here. So what we got was, let me just use yellow over here. So we got predecessor, and then it's going to go to the node that's being inserted. That node is going to the successor. and the successor might go somewhere else, right? That's one direction. What about the other direction? So think about, we got the successor over here. Its previous node is referring to the node being inserted. That node being inserted, its previous should really be pointing to the predecessor, and the predecessor will point to by its previous node to whatever it has been pointing to, right? That one hasn't changed, right? So that's really the structure you want to make sure you understand, right? If I can just do one more illustration, you can see that. So this one here, this one over here, and this one over here, and this one over here. So this is one direction over here. And what about the other way around? So you can think about the successor, and then its previous, and then its previous, and also its previous. So this would be just another direction, right? So these are the bidirections we have set up. You want to make sure you really understood exactly what's going on. What about the running time? The running time will be actually quite straightforward. You can see we are calling the helper method over here set next, set previous, and also no construction. Those only involve about variable assignments. So it's really primitive operations without any loops. In that case, it will just be added up to a constant amount of time. So the running time is simply big O of 1, right? It's really easy to justify. Hopefully that also makes sense to you. Right, so the constant amount of time. And this helper method, you will see how incredibly powerful it is. And it's constant time, by the way. All right, let's now go back to the slides, and then we're going to see, given that it's actually constant amount of time, so we can use that whenever we want to. And the line that actually calls upon this method will also be constant time asymptotically.